Right, Sipo and Jerry are pulling a log of mass 35 kg across a rough horizontal surface. Sipo is applying a force of 30 newtons to the west, while Jerry applies a force of 150 newtons at an angle of 60 degrees to the horizontal, as shown in the diagram. The log experiences a frictional force of 5 newtons to the west. Right, let's start with the definitions here. We have defined the term net force. Net force is the sum of all the forces there acting on an object the sum of all the forces acting on an object there is the vector sum. Same. The vector sum of all the forces acting on an object there, that would be the net resultant force there. Net force or resultant force there. And let's get Newton's second law out of the way as well. Newton's second law states that when a net force acts on an object, let's see there. So, go for 5.3. Newton's second law says that when a net force acts on an object, the object accelerates. The object accelerates in the direction of the net force now this acceleration, the acceleration is directly proportional to the net force and inversely proportional to the mass of the object there. When a net force acts on an object, it causes that object to accelerate in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object there. And that's Newton's second law there. And with the definitions out of the way, let's get to the free body diagram there. 5.4, the free body diagram there. So what do we have here? Without going into components of Jerry's force there, the free body diagram would be we have the big dot, we have gravitational force from the earth, and we have normal force from the surface, and we have Sipo's force F-Sipo to the left, and we have Jerry's force there. Jerry's force there. Now the question is, in what direction will the friction be? Will it be to the right, or will it be to the left? And in the case whereby like we do have now, in this case whereby we have two applied forces, we need to determine in what direction is the bigger force there. But Jerry's force is at an angle there, so you need to determine the horizontal component of Jerry's force there. So, and compare it to Sipo's force there. So we are going to say that the horizontal component of Jerry's force will be the force multiplied by cos theta. So it's going to be 150 cos of 60 degrees. And then what we have here is 150 multiplied by cos 60. It gives us a 75 newtons there, and it is going to be to the right there. Now there is the horizontal component of Jerry's force, is 75 newtons. So we compare 75 newtons of Jerry's force and compare it to 13 newtons of Sipo's force, and we conclude that Jerry's force wins. So Jerry's side wins. It means Jerry has a bigger horizontal component force than Sipo there. So the object is going to accelerate to the right. The net force is going to be to the right there. And if the net force is to the right, the object will accelerate to the right, and therefore the frictional force will oppose that motion and be to the left there. Now, that's the sort of thing that we have to do whenever we have more than one applied force there. We need to determine the direction of motion first by calculating which side is going to win, which side has the bigger force or forces. If there's more than one on a side, then we have to combine those forces and add them and find out. We have to make that determination there. All right. For the marks part, 2 marks for defining net force and 2 marks for defining Newton's second law. And the marks for the free body diagram is each one, 1, 2, 3, 4, 5 there for the free body diagram there. Now, it says there now, determine the magnitude of the net force. Now we go back to 5.2 there because I think that it's important to have the free body diagram before starting to calculate the net force and the acceleration. So free body diagrams guide us in terms of how we are going to write our net force equation there. So now 5.2 now going there. We have already said, it's difficult to do 5.2 without doing 5.4 first, without drawing the free body diagram and getting a picture of how our forces acting there. Now, with that said, it's also important to see Jerry's force in terms of its components there. It's a force with a horizontal component to the right and a vertical component upwards there. So for the net force equation, we are going to say that the net force is equal to, we focus on the horizontal forces. So Jerry's force, let's start here. We said that the direction of motion is to the right. So let's choose to the right as positive there. Jerry's force will be positive whereas Sipo's force will be negative, as well as the frictional force will be negative to the left there. But Jerry's force focused on the horizontal only. It is his horizontal component, is a horizontal component of Jerry's force minus Sipo's force to the left, minus the frictional force that is also to the left there. We have calculated that the horizontal component of Jerry's force to be 75, minus Sipo's force is 30, and we are told that the frictional force is 5 newtons to the towards the west there. So that's what we're going to get there. So actually it's going to be east because you are given direction in terms of east and west. So we choose east as positive there. This will give us a 75 minus 30 minus 5 equal to, this is going to give us 40 newtons there. A positive answer means that we have a direction of east because we chose east as positive there. 4 marks for this one. So I think it's 1 mark for the formula substitution, the answer as well as the correct direction there. Then now that we have the net force now, a 5.5 there, calculate the acceleration now. With this acceleration calculation, we are going to emphasize on what we have just said there. We said that we are going to start by saying the net force is equals to mass multiplied by acceleration. Let's recalculate that net force. So what do we have again? We have east as positive. We decide that Jerry's force is positive because the direction of motion is to the right or east, and therefore Sipo on the left is negative, as well as the frictional force is negative there. So below net force here, we have, for net force, we have the horizontal component of Jerry's force minus the force of Sipo minus the frictional force is equal to mass multiplied by acceleration, whereby we have 75 minus 30 minus 5 is equal to a mass of 35 there. This gave us 40. Let's have that A there, equal to 35A. Divide by 35. Divide by 35, and the acceleration is going to be 40 divided by 35, giving us 1,14 meters per second squared. It's positive, therefore it is to the east as well. So 1 mark here, 1 mark there, and 1 mark there, and this one is out of 16 there.